Good evening, students. This is Deekam Pathak from Freebirds Experiences, and I welcome you all to this wonderful series called Fun with NCERT. So today's session will be taken by Mr. Rupesh Mandal. So without any further ado, let's get started. Mr. Rupesh, please do continue on with the session. Thank you.
Thank you, Deekam, for handing over the session to me. First of all, I would like to introduce myself. My name is Rupesh Mandal. I am working as an assistant professor in the Department of Computer Science and Engineering in Assam Don Bosco University. So I would like to thank Freebirds Innovation Hub Shillong Science Center for giving me the opportunity to present some lecture on science. So this is like fun-based or activity-based session. We have this sort of topics you have in your NCERT book. So there are a lot of activities, there are a lot of things to understand, and we will try to make you understand through some sort of activities. So let's go through like what we can have in today's topic. So in today's topic, we will be basically discuss about metals and non-metals. So let's see what are all those things. So we all know that we are actually coming across a lot of objects which are either metal or non-metal. So we can classify them. So any object which can be either a metal or can be a non-metal. So let's go through first of all the basic definition of what exactly is a metal. So metal is nothing but it's a solid material which is typically hard, which is shiny, which is malleable, which is fusible and ductile with good electrical and thermal conductivity. So how can we define a metal? Like a metal can be a thing which is either shiny, or these are the sort of property that metal should show. Like it can be shiny, it can be malleable, it can be fusible, it can be ductile, and it should have a very good property of electrical conductivity as well as thermal conductivity. Okay, and in other definition we can say metal of an class of substance that characterized by high electrical and thermal conductivity as well as by malleability, ductility or higher reflectivity of light. So we know in nature or in common thing we have a lot of this kind of like metal substances which are available. For example, we have iron, the best known metal, then we can have copper, we can have bronze, we can have aluminium, we can have gold. So there are a lot of these sort of metals which are actually available in the nature, and we are actually using all those things in our day-to-day life. Okay. Now, how exactly these metals are different from non-metal? So we have to go through the non-metal as well. So non-metal can be defined as a chemical element that is not a metal, for example, carbon or oxygen. So definitely all those things are also available in the nature, but how it is basically different from the metal. Okay, so non-metallic metals are the solids or gases. So we can categorize like metals and non-metals. Metals generally, or like it is the property of the metal that it should be solid. Okay, and on the other hand, if we say non-metal, it can be a solid or a gas, and they are not a good conductor of electricity and heat as well. So if any substance which is not a good conductor of heat, or it's not a good conductor of electricity, and even if it is a even if it is a liquid or gas, okay, so those things can be considered as non-metal. For example, water we have, it is a non-metal. All the gases we have, oxygen, carbon dioxide, nitrogen. Okay, so all these things are coming under non-metal. Then we have solid substances also like wood and other plastics and all those things which are solid definitely, but the other properties like they are not showing electrical conductivity, then thermal conductivity. So those things are actually not shown by the non-metal. Then chemical elements that form negative ions, like in more detail it is written like chemical elements that form negative ions have acidic oxide and are generally poor conductor of heat and electricity are called as non-metal. So these are the chemical element basically. Like in more chemistry definition, it is mentioned that if it is forming a negative ion or have an acidic oxides, if it is forming acidic oxides, so these things are generally non-metals. For the example that I have given, like it can be a plastic, it can be a wood, or it can be water, paper. So all those things are the composition of all those things doesn't say that it is a metal. Okay. So next we are going to understand about various physical properties of the metal. Okay, like how a metal should be and what are the physical properties. So physical property means by seeing or by touching them we can identify that whether that particular substance is a metal or not. So the first point, it is mentioned that metals are solid. So as we know, like metals we are coming across like iron, aluminium, gold, copper, titanium. Okay, so all those things are solid enough. So this is the first point. So metal should be solid. Then the second one is metal should be hard. Fine. We also know this one, that metals are hard. For example, iron, we use iron for any construction of structures and all. We use those iron combining with some other element to form steel. So those steel rods or iron rods are actually kept inside the RCC building to make the structure strong. So that is called hard. Then metal are lustrous. That means it is going to give some sort of luster, like shiny, like the metal should provide some sort of reflectance, like shiny appearance. Okay, so that is the property of metal. Like definitely, if we have a very new piece of iron, and if or in any iron, if we try to rub the surface of the iron with a proper thing, so you will get a shiny appearance. Similarly, silver. Okay, so if we have a silver and if it is properly polished, and it will give you some sort of like reflectance property. Okay, then gold. So all these metals, if the metals are, the body is properly washed, or if it is properly polished, we can have a reflectance, or we can there is some sort of shiny thing that is actually we can have observable. Then metals are malleable. Okay, so we can form like all the metals. The property of the metal is malleable, which means we can form like thin sheet kind of thing. Suppose we have a small block of metal, and we are inserting putting some sort of pressure, or suppose we are hammering that particular metal, and it is going to take the shape of one sheet. So from a block it is actually taking a form of sheet. Okay, so metal should have that sort of property. Okay, suppose a iron block is there and I am just hammering that particular iron block for a long time. So after certain time you can see that iron block will become very thin, and it is almost like a kind of sheet. So that is the property of malleable. Okay, then the best example you can see, we can have that particular thing as aluminum foil we are using, right? So for covering up the food items and we are using those aluminum foils. So those are actually aluminum is having a good property of malleable, and it is easily available. So we are using those aluminum foil kind of thing. Okay, the next one is metals are ductile. So ductile means it can be stretched for it can be stretched in a string or something like that. The best example is gold. Okay, so the very important and very good fact that if we have 1 gram of gold, and if we have a proper mechanism to make a string out of that particular 1 gram of gold, that string can go up to 3 kilometers. That is the property that gold is having. It is highly ductile. You can stretch that particular metal till 3 kilometer, like from 1 gram of gold. Okay, so metals are basically ductile in nature. Definitely it varies from property to property, like metals to metals, they are having a varied ductility property. Like definitely with iron it is slightly less ductile as compared to gold, then copper. Okay, so those things are there. then metals have a very high melting point. High melting point means if we have a metal, for example, I have iron, and if I try to heat, and in the same way, in the same time, suppose I am just trying to heat a plastic bottle, so definitely the plastic bottle will melt out, okay, and the iron bar or iron, that particular rod, will definitely long last for a longer time. Okay, so that is all the metals are having high melting point. Similarly, all metals have high boiling point. So after melting, then boiling, so definitely it all the metals are having that much threshold of temperature that it like the boiling point, it is very much high as compared to the solids like other non-metal thing. Okay, then these metals are very good conductor of heat. Okay, so the best example is the all cooking utensils, right? We use steel. Before steel we were using iron, so whatever we used to cook in the iron container, so basically instead of iron we could have used the what you say, a container made of wood, a container made of stones. Okay, so definitely stone containers were there, but people came to know that if we have a metal and those the conductivity of heat is very good as compared to other rocks and all or stones. Okay, so heat conductivity is very good in case of metal. So why won't we use metal for cooking purpose? Okay, so that is why like all the metals have a very good conductor of heat, and definitely it varies from different metals to metals. Then metals are very good conductor of electricity. For example, like all the wires that we are using, so inside that wire definitely there will be some sort of metallic wire actually present. So in all the wires are actually coming up with some sort of plastic coating, PVC coating. Okay, those coatings are basically coming because it should not. There are two points are there, right? Positive and negative. Okay, so we should not touch those metallic strips, so basically the wires are coming with those plastic or PVC coating. But inside that PVC coating, we definitely have some sort of metals. Okay, and the best thing that we are using inside the wires are copper wires. Okay, so copper is a very good conductor of electricity, and the loss of electricity is very less as compared to any other metal we have. Okay, so and it is like cheap as compared to the costly metals like gold, titanium and all. So that's why we are using copper inside the wire. So because the conductivity, like electrons can flow inside those metals are very good, so definitely we are using metal. So if we are using any non-metal instead of those coppers, so for example consider if the wires inside that PVC, if we don't have any copper wire, so will it going to conduct electricity? Can we send electricity from one end to the other end? So if metal wires are not inside that, so definitely no. Okay, so based on that, the PVC is a bad conductor of electricity. So that's why PVC is being used as the cover coating of that particular wire. So even if you are touching that particular wire and electricity is there inside that wire, okay, so definitely you are not going to going to damage your hand. Okay, so these are the few properties, and the last property is metals are sonorous. Okay, that means it is going to produce some sort of sound. So if you try to hit two metals, okay, it is going to produce some sound. So suppose iron bell is there and you are holding an iron hammer. If you beat the hammer, like if you are just beating the iron bell with the hammer, so definitely it is going to produce some sort of sound. And this sound definitely differs from if you try to hit the iron bell with any other item. Suppose you are hitting the iron bell with a hammer which is made up of iron, or the other hammer may be made up of wood. So we can observe like what kind of sound we are actually generating. So metals which are actually sonorous in nature, so it is going to produce some sort of sharp sound. If you try to hit the same bell with wooden hammer, so definitely some sound will come, but it is not as sharp as the iron hammer. Okay, similarly if you are just hitting two iron rods together, it is going to produce some sort of sonorous sound. Okay, so by this we can say that these are the few physical properties that metals are having, but there are certain exceptions, and we will also discuss those exceptions, like how and why basically those exceptions are there and how to deal with those exceptions. So we this ends the physical property of metals. Then we will check the physical properties of non-metal. Okay, so non-metals may be solid, may be liquid or gases. So as I discussed, it can be a solid, it can be a gas, or it can be a liquid as well. So water, plastic, then gas, then any sort of gas, then wood, coal, stones, rocks. So all those things are actually solids in nature. Okay, but the problem is that those solids, suppose if we consider wood, okay, wood, if it is a solid definitely, and in some cases, like some woods are even harder than some metals also. But the problem is that even if it is a solid, but it may not have any like deficiency in any other property. So that what, like solids, even if it is solid, so it is not coming under the metal. So that's why I'm saying metals, non-metals may be solid, liquid or gases. Then non-metals are generally soft as compared to the metals. Then non-metals do not have luster. That means it is not going to give you some sort of shiny appearance. Then metals are not malleable, like as the property of metal we have, like we can make a small brick of metal, okay, into a thin foil or thin sheet. So that is a malleable property. So if we try to do with the non-metallic thing, for example wood, if we start beating the wood, definitely the wood will break at some point of time. Okay, it will start becoming powder, but it won't convert into a sheet. Okay, suppose we have a coin, we have coins, right? 1 rupee coin, 2 rupee coin. So if we start beating that 1 rupee coin or those kind of thing, so definitely it is going to expand because of the property of malleability. Okay, similarly in the same size, suppose we have a what I can say, okay, let's take the example of a rock. Okay, suppose this almost this circular shape, we have a rock. So if we try to hit that rock, okay, what will happen? Definitely it will start breaking, and it will start forming like small portions and start forming the powder. Okay, so definitely these like non-metal things, they are not malleable. So if you found some sort of malleable like items or substance, you can consider that particular as a metal. And like with that property, you need to also check the other property as well. So we need to have a look for the other properties as well. Okay, then the next one is non-metals are not ductile. Like as we said that we can stretch, or we can, if we have a metal like gold, we can stretch that particular gold to a very long distance. Okay, yeah, and this sort of non-metal things we cannot stretch. For example, wood, we cannot stretch it, right? So whatever shape it has been formed, so it is finalized. Rocks, whatever shape and size it is formed, so it is finalized. So there is no possibility of any stretching. Okay, but definitely there are some non-metal things, like for example fibers, or we can say silk or elastic thing that we have. So it can we can stretch those items for a like few distance, but definitely it is lesser as compared to the non-metallic thing. So that's why we consider the non-metals, it doesn't have a ductile property. Okay, then non-metals which are solids and liquids have low melting point. Okay, so for example plastic, if you try to burn a plastic, it is having low melting point. Similarly those waters, so it is, so non-metal which are solids and liquid will be having low boiling point as well. Okay, then non-metals are bad conductor of heat. Okay, so any non-metal, for example wood, so those are bad conductor of heat. For example, we are using tawa or any sort of cooking stuff which are whose handles are might be made of wood. Earlier it was coming as the handles are coming with wooden kind of material. So because of this particular property that non-metals are bad conductor of heat, so that's why we are using handles or covers or those kind of thing as wooden thing. Okay, so instead of, suppose we have a tawa, okay, or any cooking container, and the handles are also made of the same material. So if you cook, if you apply heat on that particular utensil, so if you try to like hold that particular item with your bare hand, so definitely it will like you will get a burning sensation. Okay, so that's why instead of that metal we are using wooden or any sort of plastic thing, so that you are not going to hurt your hand. Okay, and metals are also bad conductor of electricity. The example I have explained earlier, like PVC coating above those around those wires are basically there in order to make it a bad conductor, so that electricity will be flowing inside, but it should not harm, or like the people should not be getting harmed with that one. Okay, then non-metals are not sonorous, so it is not going to give you some sort of like very sharp sound if it is getting like hit with any material. For example, wood, if you try to bang a wood, okay, so definitely it is not going to produce sonorous sound as the metals. From the metals you can hear. Okay, you try this kind of experiment, like if you had a metal sheet or suppose metal plate. Okay, you try to hit that metal plate with a marble. Okay, glass marble, like you try to hit. So, and on the other side you can have a like a wooden or plywood kind of thing, and you try to hit that. So definitely you will have a difference in the sound, because the metals are sonorous, and why that like the non-metals are not sonorous. Okay, so these are the various properties, general properties of the metals and non-metals that we have discussed. So based on this property only, lot of things are actually available in the nature, and lot of things we are actually using in that way. Okay, and it doesn't mean that like non-metals we are using, it is not like it is not having the property of metal, and these non-metals are bad thing. No, it is not like that. So everything has its own property, and because of that property we are using, and we are actually implementing in various sectors. Okay, so if we suppose, for example, if we have a metal, so everything will have the good maybe a very good conductor of electricity, so everyone will get a shock, right? So there is equal opportunity for all of these metals and non-metals, so that's why we are having metals and non-metals. Okay, and these the properties that we have discussed. And in the earlier case, as I have said, that there are certain exceptions which are available, and I will discuss those exceptions later. Okay, now we will discuss about the chemical properties of metals. Okay, so in the chemical properties, like if it is a chemistry thing, so definitely there will be some sort of reaction. Okay, so metals also, even if it is hard, metals also react with like oxygen, with water and other substances, okay, to form certain things. So let us see like how this actually metals are having the chemical properties. So the first one is reaction with the oxygen. So metals react with oxygen to form metal oxides. Okay, these stuffs actually we cannot do, because all these things are chemical things. So we need to have all those stuffs ready. Then only we can have those experiments. Then some metal oxides are basic oxides because they react with water to form bases. Okay, like in some metals, it is forming metal oxide. So when it react with water, and it is basically forming bases. Some metal oxides are acidic and basic properties as well. They are called as phosphoric oxides. Okay, then we have aluminium. In that we are having basically aluminium oxide and zinc oxide. Okay, next we have like metals like potassium and sodium react vigorously with oxygen and catch fire if kept in open. Okay, So this is one sort of discrepancy or one sort of exception we are having. Okay, so as we said in the as we read in the physical property that metals are generally having highest boiling point or highest melting point. Okay, but here if we look at this particular statement, like metals like potassium and sodium, these are also metals, and if we are keeping it in a open air, okay, it start catching fire. So without applying any fire, it is like it by itself it is actually catching the fire. So that means definitely its melting point and boiling point is very low as compared to other metals or other non-metals. Okay, so this is one sort of exception. So we will try to understand why exactly this is actually catching fire and how to control this kind of thing. Okay, then if magnesium is heated, it burns with a bright flame. So if we heat magnesium, definitely it burns with bright flame. If iron is heated, it glows brightly. Okay, so if you have a look at any iron ore or metallurgical activity, okay, like if you start hitting the iron for a very long time with a very high amount of heat, so it start glowing, some orangish color you will be you can observe. Then if copper is heated, it does not burn to form, but it forms some sort of black coating on the copper. Okay, and it is basically copper oxide. Then silver and gold does not react with oxygen even at high temperature. Okay, like because of like silver and gold, it even if we are keeping it in the high temperature, so it does not react with the oxygen. Yeah, definitely iron will react with the oxygen, so some amount of iron will be lost. And copper also, when you are heating, and if oxygen is there in that environment or in the open, so definitely we have oxygen, so it is going to form copper oxide, so some amount of copper will be lost. But silver and gold are such kind of things, so even if we are heating it in a high temperature, it does not react with the oxygen. Okay, so if we have suppose 10 grams of gold, and we are heating that particular gold for very high temperature, okay, and after suppose 1 hour, or suppose let's take it we are heating that particular gold for 24 hours, okay, with a very high temperature, then also if we have used 10 grams of gold, after 24 hours if we apply it for cooling, we will get 10 grams of gold only, because it doesn't react, the gold doesn't react with the oxygen or any substance around it, and that amount will be intact. Okay, similarly silver is also one kind of metal that in high temperature if we heat it, so it is not going to react with the oxygen, so there is no loss of those kind of material. Okay, so these materials are very least reactive. Then we have reaction with water. Metals react with water to form metal oxides or metal hydroxides or hydrogen. Then sodium, potassium, as I said, it reacts with cold water to form sodium hydroxide and hydrogen. And in fact, if we are using sodium inside water also it is actually catching fire. That is one property of sodium. Okay. Calcium react less violently with water to form calcium hydroxide, and water does not catch, in that way water doesn't catch fire. Okay, then magnesium react with hot water to form magnesium hydroxide and hydrogen. Okay, so all these things are metal, but they are actually reacting with the normal thing. We are not implementing any other chemicals, any other element to it, just with water. Like what is water? H2O, it's hydrogen oxide. Okay, then we are using even if in some metal, if we are keeping it in the open air, so in the open air what are the elements we can have? We can have oxygen, nitrogen, carbon dioxide. So with oxygen, these metals are actually reacting and it is actually burning. We are actually saying it is actually burning. Okay, so this is all because of this reaction with different agent. So one thing we have studied earlier, like reaction with oxygen, okay, or we can say reaction with the air. Now we are actually studying about the reaction with water. So these metals are, as we say, these things are hard, solid, but these things are also react in like with respect to different thing. Okay, metals like aluminium, iron, zinc react only with steam to form metal oxides and hydrogen. Okay, like if we have aluminium, iron or zinc, and if we have a steam, then only it is going to form some sort of iron oxides. Okay, metals like lead, copper, silver, gold do not react with water. Okay, if you dip all those things like copper we have copper, sometimes we have copper utensils, right? So we have gold, then we have lead. So if we are dipping it in the water, so nothing is going to happen to that one. Okay, there might be, suppose we are using a copper utensil and we dip that particular copper utensil inside the water for suppose 1 week or maybe 1 month, so it is not going to rust. But on the other hand, suppose if you dip a iron rod in water, suppose like slowly and gradually it start rusting. You can see that some amount of rust is actually getting formed. So what is that particular rust? It is nothing but that particular metal is actually getting oxidized. Okay, iron reacts with water or iron reacts with the oxygen that is present in the air to form the rust. Okay, but if we have the copper, okay, it is not going to react in the water. Okay, definitely there, if some sort of microorganisms are present in the water, it may form some sort of greenish shades or something like that. But in general, copper doesn't react with water, it will be intact. There is no loss of the copper. Similarly with silver and gold. Okay, so it is not going to react with the water. Then there are certain metals which also react with the acid, like reactivity varies from metal to metal. And for above this metal we have, just a second, yeah, for like this metal we have order in the decreasing reactivity, like magnesium is having the highest reactiveness with the acid. Then we have aluminum, we have zinc, we have iron. So these things, like we have the reactivity level. Then copper, silver and gold do not react with dilute like hydrochloric acid. Okay, even if like hydrochloric acid, even if we are using with we are using the diluted form of hydrochloric acid, not the concentrated one. Okay, even if we are pouring that hydrochloric acid directly on copper, silver or gold, it doesn't react. Okay, like why we are keeping the hydrochloric acid or all those chemical items inside the glass container? Why not any metal? Okay, because in those cases it may happen that it will react. Okay, definitely copper, silver, for a few cases we have utensils. Okay, but as gold and silver are very precious thing, we cannot find it easily. So in some cases we are using copper, but glass substance are very much less reactive with these acids and other chemicals. So that's why in most cases we are keeping all these reactive materials. For example, hydrochloric acid. This is the common thing. Okay, so these acids, if you like, if your skin is actually come in contact with this hydrochloric acid, even if it is a diluted form, so your hand will burn. Okay, so in the chemistry labs, those things are very vulnerable things, and you people have to use a very like safe procedure if you are doing any sort of practicals with those experiments with those chemicals. Okay, then hydrogen gas is not evolved when metals react with nitric acid, because it is stronger oxidizing agent and oxidize the hydrogen produced into the water, and it's reduced to oxides of the nitrogen. So this is another aspect where we are having this sort of things. So these are certain chemical properties of the metal. So I am not discussing the chemical properties of non-metal. So let's check what is there. This is the reactivity series of the metal. So we have various metal listed which we commonly know, like potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. Okay, so if we check the reactiveness, okay, potassium is the highest reactive metal as we ever know. Okay, and gold is the least reactive metal. Okay, as we have studied, like gold, it doesn't react with water, it doesn't react with oxygen. Okay, similarly, next one is silver. It doesn't react easily with water and all. Okay, similarly, mercury, copper, and the list goes up. But if we consider potassium or sodium, okay, these things we cannot keep it in like open air also. It is going to react so fast. Okay, so this is another aspect. Next, based on this reactivity series, we will discuss one thing. Okay, so we will do a activity. Okay, so we will have this sort of arrangement. So what we need to have a metal rods or stick, a candle, a holder, small size iron or paper clips we can use. Okay, then we will place these nails and on the metal rod and in certain distance and pour some candle wax on top of that particular thing so that it can hold for some time. Okay, so I will do, I will stop this presentation and I will switch on my camera. Okay, let me change the camera angle. Okay, so what we need to have this kind of metal strip, okay, or metal rod. So here I have a metal rod available. Okay, and then we need to have some sort of paper clips. Okay, we need to have one candle. Okay, so what we will do, okay, we are actually supposed to make this kind of arrangement. Okay, so in this particular experiment, what we are actually checking, the conductivity property of the metal. Okay, that heat transfer is very good in case of metal as compared to non-metal. Okay, so we are actually trying to make this kind of arrangement. So like just by putting the wax on this paper clip, so it will actually like fix those paper clip on the metal strip. Okay, but and what we will do, we will apply heat from one end. Okay, and we will check like how heat is actually flowing. Okay, but just for like time constraint, what I will do, I will make this distance less, so I will keep it in this way, very close. Okay, so let me light this candle. Okay. We will apply, like we need to give some time for cooling that wax. try to fix the other clips as well. Instead of this paper clip, as I have this paper clip, but instead of this paper clip, what you can do, you can use some small nails also, and you can dip that small that flat portion of the nail in the wax. Okay, so I will wait for some time, then I will fix this one on in the holder. So this is ready, you can see. Okay, so I have kept this rods at different distance. Now what I will do, I will use this holder. So I have this holder with me available, but what you can do, you can also use two like blocks or bricks if you have, okay, in your which is actually easily available. Okay, then what I will do, I will start hitting from this portion. Okay, and this is very much horizontal, you can see. Okay, fine. So okay, so I'm applying heat from this end. So I'm heating this iron rod, basically it's a mixed one, steel. So see, the first paper clip dropped. So why this happened? Because we applied heat here. So heat transfer actually is happening in this direction. I can touch this portion, but I cannot touch here. It is very hot. Okay. So heat is actually flowing from this direction to the next one. See, the second also has fallen because the heat has transferred from actually transferring in this direction. So if I keeps on hitting this iron rod, so at some point what will happen, I can also feel the heat in this side also. Now I can touch because it is not that hot. Okay, I can feel some hot sensation, but it is not that hot. Okay, but I cannot touch here. It will be very hot. And as we know that for wax, right, we have a like very less boiling and melting point as compared to metals. So I have used wax in order to fix that particular item. Okay, so see, the third one is also losing its grip. It will, yes, it fell. Heat, like that much amount of temperature has attained. So why it is falling? Because for wax, it attained that temperature. It's attained the boiling temperature, or it attains the melting temperature basically. So when that temperature has attained, so in that point the wax got melted and it is losing its grip. So the paper clip which was here, So in this portion, the temperature is very high. Okay, so in this portion, the attainment of that particular temperature is very quick. But then the next one, so the portion where from where the third clip has fallen down, so in this portion the temperature attains at slow, because heat is actually flowing. Heat is more in this portion, but heat is less in this portion. Now if I can touch, yeah, it is getting warm. I can still touch it, but it is warm, but I cannot touch here. You can see some droplets of wax as well, this one. Okay, so this particular experiment shows that metals are very good conductivity with heat. Let's see how much time it will take to reach that portion. Yeah, okay, so that melting point of wax has attained in this point also, so that's why that particular thing has fallen. Okay, so in this experiment what we have learned that metals are very good conductor of heat. Okay, so I have used this small candle only, but if we can use a very good source of fire or good source of heat, so the temperature can be attained very quickly. Okay, so you need to do this experiment very carefully because it may cause some sort of damage. Okay, so you need to be very careful with this. Okay, so I will switch off my camera. Okay, I will start presenting my presentation once again. Okay, so from one point we actually started the heating, and we have seen that how heat is actually transferring from one portion to the other portion. Okay, and finally heat has been attained. Okay, so what is actually happening over here, even if we are actually applying heat, so there are a lot of actually physical and chemical activities actually taking place in this experiment. Okay, the first thing, the primary objective is that we have understood that metals are having a very good conductivity of heat. Okay, then second point is that heat is actually transferring from one end to the other end if we are applying constant supply of fire or constant supply of heat. Okay, then the other thing is that wax, we have applied wax in this case, in this example, right, in order to fix those nails or paper clip. So definitely wax is having a difference in the melting point as compared to the your metal. So this is a iron rod or iron strip. Okay, so this particular item has a very high melting point. Okay, so it let the wax melt within a very quick span of time, but the iron rod will be it will be intact for a long time. Okay, even if you apply the heat for 1 hour or 2 hours, it is not going to hamper that iron rod that easily. Okay, but as we have fixed that those paper clips with wax, so it attained those items has attained the melting point very quickly. Okay, as heat was transferring from one location to another location, so that's why it is actually fallen down. Okay, so this is the experiment or activity we have done. So I hope you people have understood, and you can also try this one in your home with proper supervision of your guardians, parents, or anyone, your elder brother or sister. Okay, then there are certain questions. So as I have discussed about, there might be some sort of exception that may be available, okay, with metals and non-metals. So those are the exceptions, and why we are actually we will be actually discussing those exceptions with these questions. So first question, that why we use gold as jewelers. Okay, so the answer is gold and silver basically. Okay, so gold and silver are used to make jewelry, because these metals are used in jewelry are always chosen on the basis of the reactivity. So if you remember the reactivity thing, gold and silver are very, like, these are the least reactive metals that we ever know. Okay, so if we use gold, for let's take the example of gold. So like almost most of the person, they are wearing gold ornament or jewelries. Why? Because, and why these are considered as the like ornaments? Okay, because these are least reactive. For example, if we make a iron what we can say, an iron ring. Okay, and a people is asked to wear that iron ring, just made of simple iron, cast iron. Okay, on the other hand, like somebody has given a gold ring, so that person is wearing two rings, an iron ring or a gold ring. Okay, so definitely that person needs to do some sort of daily activity. Okay, washing of hands or application of water in the hands. So as iron is actually is reactive towards water, although it is less reactive, but definitely there will be some sort of reaction with the water. Okay, and the oxygen that is present in the air. So that particular metal is going to rust very quickly. Okay, so it is forming some sort of oxides, and it is, in general, we are saying it is actually rusting. Okay, so rusting things, like are we able to wear those rusting things? No, we are not supposed to do. And the other aspect is that if it is a rusting, so that means it is losing its weight. Okay, so even if we don't apply any force or pressure to those metals, okay, it is actually with the help of those chemical reaction with water or with oxygen, it is actually losing its like weight or losing its volume. Okay, but as we said, gold is the least reactive metal. So even if you have purchased a gold ring of suppose 5 gram, okay, so after 10 year also, if you have used also, so if there is no application of any force or friction to those things, so that 10 gram of gold will be like 5 gram of gold will be 5 gram after 10 year, or maybe after 20 or 30, or maybe after 100 years. Okay, there is no sort of like you can say reaction with water or with oxygen. Okay, and these materials are very expensive, or why we consider these as like jewelries, because those things are very precious. We cannot easily find those things in like in normal thing. Okay, we have iron ores, but we have gold mines. So mining of gold, like extraction of gold is a very like difficult job. Okay, and the other thing is that it is very least reactive, the most important point. Okay, so because of that one only, we are using gold and silver as the jewelry. Okay, next one is why sodium is kept immersed in kerosene oil. Okay, so if we take out kerosene in our bare hand, or if we try to put the kerosene inside water also, okay, what will happen inside water also? It is actually burning. Okay, sodium is a highly reactive metal and react vigorously with the oxygen, carbon dioxide, and moisture present in the air. Okay, and in such cases, there are cases that it may even catch fire. Okay, so if there are more moisture that is present in the air, so it may even catch fire. Okay, and if you dip that particular like sodium inside water, so definitely it will catch fire. The diagram or that image is showing that inside water it is actually catching fire. That fire is nothing, that is actually a sort of chemical process that is actually going on. Okay, so in order to prevent this explosive reaction, in order to prevent sodium to get react with either air or either oxygen or water, okay, we will put this sodium inside the kerosene, because kerosene with sodium it doesn't react. With kerosene it doesn't react easily. Okay, and the property and that particular like metal will be intact. So that's why in most cases the figure that I have kept above, like so that sodium is actually kept inside the kerosene. Okay, then another question is that why mercury is used inside the thermometer. Okay, because first of all, I want to say that this is one sort of exception, right? We said that we said that we already have discussed that metals are generally hard substance. Okay, those are very difficult to break. Okay, so but why this particular metal? Like we consider mercury as a metal. Okay, so definitely there will be certain property, but mercury, it is in the room temperature also, it is actually in the liquid form, but still we consider mercury as a metal. The first thing, why we need to consider mercury as a metal, because it is having the property of electrical conductivity, and it is having the property of it is good conductor of heat. Okay, so based on those two property, we consider this particular mercury as a metal. Okay, and because of this property that it can attain liquid form. Okay, it can attain liquid form in a very low temperature, that is a room temperature. Okay, we can use inside the thermometer. Okay, and it actually expands. So when temperature is low, it will be in the in like how the thermometer looks like. Okay, so there will be some sort of mercury that is present on the bottom portion. So when that portion is actually getting in contact with the temperature, so if you apply heat, so the temperature, that mercury level will rise, and we can calculate the temperature, how much temperature it is there. Okay, so because if we apply heat, it start expanding. Okay, it is actually it is in solid form for some time, but if we apply heat, it becomes liquid and it is start expanding in the above direction. So that's why we are using this mercury inside the thermometer for measuring the temperature. Okay, and mercury is the only metal that is in liquid state at room temperature. Apart from that, all the metals what we know, we have all the metals are in the solid state in room temperature, and its melting point is also less, as we have seen, but it doesn't boil. Okay, even if we apply heat, it will be in that liquid state, but from the liquid state, it is not changing to gaseous state. Okay, so that is why we also consider this one as the metal. Okay, one more exception is there. Lead is one sort of metal which is hard, which is less reactive in water, or less reactive with oxygen. Okay, but what we have, that lead is a bad conductor of electricity. You cannot transfer electricity, or that particular item is not conducting any electricity. So that is one more exception. On the other hand, we have discussed that all non-metals are bad conductor of electricity, but there is a certain thing which are actually are coming under as non it is coming under as non-metal, but those are also a good conductor of electricity. The best example is the graphite, the thing that we used inside the pencils, right? Graphite pencil. So inside that wooden thing, we have a black color object through which we are actually getting that shade, black color shade, right? So that is made up of graphite. So that graphite is actually a very good conductor of electricity. So we can transfer electricity through it. Okay, so these are the various things that we have discussed about metals and non-metals. We have discussed properties, we have done that activity, and I hope you people have got some certain idea regarding all this. So this is all about from my side for today. Thank you.
Thank you, Mr. Rupesh, for the wonderful session.
Yes.
Yeah, thank you so much, and hopefully and hopefully the students also had a good time, and let's rejoin again. I think tomorrow is the next session, right? If I'm not mistaken.
Yes, tomorrow we can have the next session.
Great. All right.
So yeah, students can have a look in their NCERT textbook. Like this kind of activities are also mentioned over there, and have a practice with your parents, with your friends. But definitely I would suggest that whenever they are doing these activities, just make sure they are doing it safely and with proper supervision of their elders.
True.
That's all. Thank you.
Definitely. Thank you so much. Bye-bye. Good night.
Okay.